Now this session I am going to explain another basic tool which is current division principle. One of the important and very useful techniques in the analysis of circuits is current division rule or current division principle. Imagine there are two resistors in parallel. There are two resistors in parallel. A current of I amperes is coming like this. A current of I1 is going like this. A current of I2 is going like this. As you know, according to Kirchhoff's current law, at a junction, this is a junction because minimum 3 paths are joined to that point. See, current I wire is coming there, R1 connected wire is there, R2 connected wire is there. So 3 paths are joined to that particular element. This is a junction. At a junction, total current entering the junction is equal to total current leaving the junction. As per the directions I showed, I1, I2 are going away from the junction, I is entering, so KCL, as per KCL, I is equal to I1 plus I2. Not only that, current I1 can be easily determined by applying the rule total current into resistance parallel to R1. The resistance parallel to R1 is R2 divided by sum of these two resistances. See the importance of this. Suppose I want to know current in R1, that is marked as I1. The resistance you need to consider is parallel to it, I into R2 by R1 plus R2. Similarly, suppose I want I2, I into, what is the resistance parallel to R2? It is R1 by R1 plus R2. A very, very useful rule or principle in the analysis of circuits. For example, see this, whatever the rule we discussed, I am applying here. Suppose 20 amperes is marked here. This is 4 ohms, 6 ohms. I want I how much? See, I marked I as the current through 6 ohms resistor. So according to current division principle, current in one of the resistors is total current into resistance opposite to it or parallel to it by 4 plus 6. So what is this? 8 amperes. Similarly, if I want current in 4 ohms, how to get current in 4 ohms is total current, resistance opposite or parallel to 4 ohms, which is 6 by 4 plus 6, that means 12 amperes. Also observe that 20 amperes current is equal to 8 plus 12. 8 amperes is flowing through 6 ohms and 12 amperes is flowing through 4 ohms. Let us take another example. I want all of you to tell me some values I am giving. I want to know what is I. I means what? The total current entering the parallel combination. So I apply the rule. Current in 8 ohms. Current in 8 ohms is equal to total current into opposite resistance or parallel resistance by 2 plus 8. Accordingly, what is I? I is equal to, this is I into 2 by 10. So what is I? 4 into 10 by 2. That means 20 amperes. This is another very useful rule or theorem in circuits.